Okay, can you hear me back there? Okay. Okay, so I covered section 36.3 changes. That was the general changes to both concrete and asphalt. Now we're just going to go through the changes that apply to asphalt. So one of the big changes has to do with the layer thicknesses. So in the past, we had these two different type of jobs, thick lifts and thinner lifts, right? We had a 60 spec, a 60 MRI spec, and a 75 MRI spec. Years ago, when we first started with an MRI requirements, we basically said the 25, if you had 25 hundredths or greater, you went with the 60 spec. So that has been now changed to 3/10 or greater, you go with the 60 spec, and now we're calling it the 60 target spec. So the purpose of this table here is just to show you the 5 different ways that we try to express 2 different things. So we used to say greater than 2/10, that's the 25 hundredths, that was going to be the 60 table. And we bumped it up to greater than 25 hundredths, which means 3/10 or greater. And we basically said the same thing, but just greater than or equal to 3/10. So we're using the 3/10 terminology to have people better understand that if you have a 3/10 lift, that's the tighter spec, because you can break those lifts up into 2 lifts typically. So the other change is that with our new specs, if you had a 3/10 lift, if you looked under the old specs, you basically had to place one lift of 3/4 inch type A. Well, that table with the lift thicknesses and layer thicknesses, that's changed now. You can use 1/2 inch HMA, 2 lifts of 1/2 inch HMA, 15 hundredths. Smaller aggregate, a lot of people don't like that, but that's how that spec reads now. So if we have a 3/10 lift, we can do two lifts. That's going to be 2 opportunities. To promote smoothness was one of the other reasons. So, is there any questions on that, or there might be a question on this later, so remember that answer. Okay, HMA Smoothness MRIs, it's a moving target. So this little guy here on the left is kind of to simulate, it's a moving target. If we're overlaying a HMA on existing pavement that's relatively smooth, it's not a moving target. If it's rough, we're going to adjust the spec limits up. It's a moving target of what we're shooting for. And it can vary by every 10th mile segment. So normally you would go into ProVal, you'd say, okay, what's my MRI requirement? Oh, it's 75. You could get your MRI report and say, look for all the MRI values that are over 75, you got to correct those. If we're overlaying rougher pavements, you can't do that anymore. All that data's got to come out of this ProVal into a spreadsheet to determine if it meets spec or not. So that's the tool that we're providing as a spreadsheet. So this slide here basically gives you an idea of when we go to this moving target. So when we talk about a moving target, when you hear the term percent improvement, that means it's a moving target. The specs adjust up if you're overlaying a rougher surface, which makes sense. If you're going to overlay a road that's really rough, 200 inches per mile, and we had a spec of 75, it's difficult for the best of pavers to get a 75 on something that's 200. So we're going to raise the spec up a little bit. So now our designers have to kind of design for smoothness. You know, they need to build in 2 opportunities, either milling in one shift and paving in a different shift, or a thick enough lift where they can break it up in 2 lifts. You know, designers have to account for that now. In the past, they basically just put a lift out and say 15 hundredths, you got to get a 75, and you know that led to a lot of claims. So we're going to make all those claims go away. We'll still get claims, but they won't be as legitimate. Not that they were legitimate, but okay. So when we have greater than 3/10 or greater, you know, we're going to use the 60 target spec, and if we're overlaying an existing road that's over 165, then it goes to percent improvement. If we're doing these thinner lifts, less than 3/10, you know, we're going to use a 75 target. And if that pavement gets too rough, we're going to adjust the spec up. If it gets rougher than 135, then we're going to say, okay, you know, you're going to have a moving target. So
for each 10th mile segment.
Yeah, okay, so this applies for every 10th mile segment. So I might have a 10th mile segment that's going off this. Let's say I have a 1500s lift. I'm going to be using the 75 target table or the percent improvement table. I might alternate back and forth between this table and that table and this table and that table every other 10th mile segment. It's going to adjust for itself. So, okay, so
Can you go back one? The ALR also is.
okay, oh yeah, I forgot to cover ALRs. So in the past, we had the ALR requirement. That was the localized roughness requirement. That's the requirement for if it was a must grind. If we had an ALR that was over 160, we say you got to fix that bump. It's an isolated bump. You got to fix it. So if we go into percent improvement, now it's basically it's going to get adjusted up if it gets into the rougher pavement. So there's a higher threshold. So this spreadsheet that we have will tell you what that spec limit is. If it's not 160, it's going to tell you when it's other than 160. Okay, so now I'm going to talk about these thinner lifts. They're not thin lifts, but they're thinner lifts. They're less than 3/10. So typically, when it's less than 3/10, it's always one lift. There's some exceptions to this. Sometimes you might do type A covered with RHMAG. You might have a 10th and a 1500s would be 2500s. That's two lifts, but still we're going to use that 75 target table. It's just the spec is based just on lift thickness. So if it's less than 3/10, it's going to go off the 75 or percent improvement table. Okay, so when you open up these specs, one of the first tables you come to is this section that says you're going to figure out what pay table you have to use. And there's the table that covers what we just talked about on the previous slide, greater than and less than 135, and we have these different sections. There's a lot of characters on that section number, but we have sections A, B, and C. It's 75 or PI, it's B and C. And here's the table. This is the adjustment. So if we have this is the 75 target table. So we're calling this a 75 target table, but the contractor could leave a 90. He could pave a 90 MRI and he wouldn't have to grind it. In the past, he'd have to grind that down to a 75. But we're going to take a deduction of up to $1,350 per 10th mile. So, he has all the incentive he needs to try to pave as smooth as possible because he doesn't want these disincentives. If he paved to 85 or something, he could grind out of it and get into full pay, but he can't grind into the incentives. So, all these values, these are covered in the spreadsheet. This is the percent improvement table. There's one table that covers, both layer thicknesses, greater and less than 3/10. On the right, we see the percent improvement table for less than 3/10. We have the same dollar adjustments. It's just this equates out to, if you're 125% of target, we'll talk about what target is, but this equates to a $1,350 deduction. And the max incentive is $450. If I go back here, we'll see the max incentive $450. Incentives and disincentives are the same under both of these tables. We're just raising the target limits. Okay, so percent improvement. Now, it's based on, when we do a percent improvement spec, we basically got to say percent, what is it we're trying to figure the percent improvement of? So if we have to come up with a target value. So we talked about the 75 target. If I have a 136, that's over 135, I'm going to have to calculate MRI target. If I do that math for one equation, I'm going to essentially come up with a number that's just above 75. So if I get a 140, it's going to gradually climb up. So these target MRI values, it's a function of how many opportunities for improvement you have. So when you go to that spreadsheet and you enter the number of opportunities, it's going to calculate all that for you. All you need to know is what an opportunity for improvement is. So
Can you go back? So if you had one opportunity, you use the 0.34 times MRI not plus 35, you had two opportunities that uses the other formula. If you have three opportunities, it uses the third formula.
Yep. Okay, so I guess I should throw out an example. Let's say we had an existing road that was 200 MRI. There's a 10th mile that's 200. And all I'm doing is putting one lift on it. And I'm not doing any milling and filling, or I'm just putting it right on top of a 200. My target value is going to be 200 times 0.3, which is 60, plus 35 is going to be 95. So that target value that we had of 75 now just got raised up to 95. So if we had two opportunities, I'll have 9% of 200, which is 18 plus 45, which is 55, 60. It ends up being right close to, it ends up being less than 75, but it's going to bottom out at 75. So there's some general rules here that when we calculate these targets for lifts that are greater than 3/10, when we calculate that target value, we're not going to let that equation give us something lower than 60, because that would make the spec tighter than what it would have been if we just had the 60 table. And if we have a table, if we have a lift that's, was under the 75 target table, we're not going to let it spit out a value that's less than 75. Okay, so all these tables that we saw before, this is kind of the way I look at it here. So the x-axis here is what we call in our spec MRI 0. This is essentially, MRI 0 is the lower of the existing or the baseline profiles. It's the surface that we're typically overlaying, that we're trying to improve upon. And here's our final MRI values. So here's our 135 number. So if I have an existing surface that's 135 or less, we're just using the 75 target table. So there's our 75 target, and these two red lines are, that's our deduction range. If we go over that top red line, that's our mandatory correction level. If we pave smoother than a 75, we get the incentive, but we've got to be, between these two green lines to get any kind of incentive, and it just maxes out the incentive. So that job that we looked at, they were paving, that plot of circles that we saw was, roughly in this area. If we plotted those plots on that last project, we would have been about here. So if I'm paving a rougher surface, the calculation I just did, 200, there's our number. It's going to be whatever that number was that we calculated. It was 95, I think. There's your 95 value. And then we basically go up from that 10%. We had 10% on a 95, and then we also had 25% on a 95 to figure out those values. So the rougher the pavement, the targets gradually rise up. And there's our MRI target value. There's our equation right there for a single opportunity. So if we have a project that is calling for a single lift and there's no other opportunities for improvement in the plans, in that existing surface out there is, in the high 100s and the 200s, we could end up accepting a pavement that has a 120. This purple line is that's what the FHWA calls the difference between a fair and a good pavement. It's 95 MRI. We don't want to go out and pave a project and end up with a surface that's fair. We want good. We want below 90, obviously. So we would never really want to accept a project up here, but we might have to if they don't design right. So, designers are being trained to basically figure out how to put two opportunities in. So this is the one opportunity for less than 3/10. So if we go to two opportunities less than 3/10, we're in the percent improvement table, but when you do all the math and all the rules, it basically, we have the MRI target value for 0.09 times MRI 0 plus 45. That's this value, but basically what it happens is it can't go less than 75, so it goes flat. So we're in the percent improvement range. And then the incentives and disincentives are based on 10 and 25% above that number, which is a little bit different than the 80 and 90 that we had under the regular target tables. So designers are being trained, like if you have an existing surface that's over 135 up to in the 300s, having two opportunities, we're going to end up with, by spec we're going to get something less than 95. So in most cases, contractors are going to be probably paving into incentives. So one opportunity, I'm going back. In the past, we might have been overlaying a road that was 250 when we told the contractor they had to pave to 75. And they file a claim, and they say, it's not reasonable. Well, we just, these specs account for that now, so.
Pete?
Yeah.
How do you guys define mandatory corrections? What is that exactly?
Okay, all right, so a mandatory correction is.
Can you repeat the question?
Okay, the question is, how do we define what a mandatory correction is? So when you go to our tables, that's the highest MRI value that you can have that's acceptable. So if we have a 75 target table, that's, we're doing a single lift, we're doing a layer that's less than 3/10. our mandatory correction level, you go to our table, it's 90, so we can go back to that table. There's that 90 value, that's the mandatory correction level.
No, I think what I meant is what entails, when they're in the mandatory correction, what does that entail for the contractor?
Grinding.
Grinding?
Grinding to get down to the acceptable limit. So if you got above a 90, if I got a 95, I paved it and I got a 95, and my existing MRI was below 135, so I'm not in that percent improvement range. I'm in the target 75, hard target 75 range, and I paved it to a 95. I have no choice. As an RE, I have to tell him he needs to bring it down, and it's mandatory
Okay,
correction.
so they're gonna grinding pave, newly
Yeah.
pave.
Yeah, so here's the big difference is like in the past, we had the 75 target. In the past, we had the 75 MRI spec limit, right? If they paved a 76, we couldn't accept it. They'd have to grind. Well, now, it doesn't really make a lot of, it depends who you talk to, if that makes sense or not. That's a threshold. Well, there's a lot of projects I saw that were paved in the 80s, 85s. You drive over them, you can feel it. It's not the greatest paving. But to get to a 75, you got to do a lot of grinding because there's a lot of little bumps. You got to grind a lot of little bumps. It's not just like a couple big bumps you can take out. You can require a lot of grinding to not do a lot of improvement, right? These specs address that by just taking a disincentive, giving the contractor the incentive to use their best paving practices. Everything is getting measured now. In the past, it typically wasn't. And, in the past where we had, you'd have an RE on one job where they paved to 80. That RE, says the spec says 75, they can't accept it. They go out there and grind. And they finish grinding all those 80s down to 75s, the whole job is ground up. You get to the next job, and the RE kind of felt sorry for them, right, and didn't enforce the spec. We have to be consistent throughout the state. So these new specs are going to, improve that. So, is there any questions on this yet, or?
So if cold planing is involved, is that considered an opportunity also?
Okay, yeah, so the question is if cold planing is involved, is that an opportunity or not? That depends. Okay, so the way the specs read, if you can cold plane in one shift and pave in a different shift, that's an opportunity.
No, it counts as a single opportunity.
That's an extra opportunity, right? If I have to mill out and pave back in the same shift, which is how our specs default to unless, that's not an opportunity. Now, you could talk to everybody in the world and they'll say, well, that's some type of opportunity, it's only intent. Yeah, that's kind of an opportunity, but it's not in our specs.
Right. What
So-
is the difference between if you pave the same shift?
Okay, so,
You have enough time to prep for the.
yeah, so when you pave in a different shift, okay, if you have a job that requires you to mill out and fill and pave back, typically you're milling out, right? And then you got to pave back flush. That adjacent lane is, your rollers are going to be having to ride on that adjacent lane. That doesn't help you, right? If you could mill in one shift and pave in a different shift, typically you can do the adjacent lane.
Yeah, I got it.
That will help you, right?
So you can grind, probably a few miles before you pave, then
Yep.
you have more opportunity.
Yeah. And also, there's like this example project I was telling you about, how they got those great sections. They had a mill, they had the spec that allowed them to cold plane the surface, leave it exposed for up to 7 days, and so what that contractor did, they went in, it was 3 lanes in both directions. They went and started in one lane, milled it out 2, 3, 4 nights, came down the other number 1 lane. They were running traffic on that surface. It was a micro mill surface. They used a micro mill. They didn't have to. They just decided to. And then they had there was long enough sections where they can come through with their inertial profiler. Not that they had to by spec, but they did. They ran their profiler over that, and they said, okay, there's a couple spots where we don't want to pave over that. We want to do what we can. They went to great extents to make that really smooth, right? You saw the numbers, the 40s, 30s, some cases 20s. It's unheard of when you talk to most contractors, but they can do it. It's just, that was 2 opportunities because they had, so. So, you know, there's a lot of, when we were in meetings with industry, I mean, there's people in construction who were saying, it's got to be an opportunity. It doesn't matter, you know, if it's one shift or the other shift. Well, there's a little bit of difference, but that's how the specs got set up. You know, everybody's bidding on the same spec, so it's fair. It just seems like, yeah. Okay, so is there any questions on, this is kind of a, I like this graph because it just tells you, shows you how things, you know, we accept rougher pavement if we're paving over rougher pavement. That's one opportunity. If we could get two opportunities, now I could, you know, I could basically get something similar to that all the way up to paving over a 328. So, you know, if designers strive for adding a second opportunity in there, you know, we won't have a chance of ending up with something that's above 95. We'll probably, you know. So anyways, that's, okay, this is a two opportunities PI table, similar to the 75 target table. You do the math, that 75 bottoms out at, use this equation and you plug in 328, you'll get the number 75. That's where it crosses the 75. So how do you get a second opportunity? Special provisions. There's a special provision that allows, if they use the special provision, they can allow the cold plain surface to be exposed for up to a week. Right now, the standard spec says you got to pay back in the same shift. If they use that, they can leave it exposed for up to a week. Now, you know, there's some districts that say absolutely no way. They've had so many broken windshields. They're never going to run traffic on a cold plain surface. I had a job like that once, and I'll never do it. You know, after I had that happen, it was like, never, ever again. I don't pay back in the same shift. So, you know, you got to be, you know, but I did it for years and years before I had that happen. Until it happened, and it was like, oh, you know, you see things differently once it happens. So, two lifts, you know, we might break, you can end up with two lifts if you have two different types of HMA with a less than 3/10. Okay, now we have this thing called full width segment correction. And I'm calling this skim grinding, but we'll cover that in a second, so that'll add a second opportunity. Okay, so we have this new section called PrePaving Corrections. So we used to have a spec that was pre-paving grinding days, and that spec didn't work out too great. You know, the spec basically said go out, contractor, and grind every spot that had localized roughness over 180. Right? There's not really, and we're paying them by the day. There's no incentive for them to be even efficient at it. You know, it was not a good bid item. It was putting all the responsibility on us and nothing on them. You know, and if they had any MRI segments that were over 180, we couldn't enforce the smoothness specs. So the pre-paved grinding day, that bid item is no more. So now we're going to have these two other bid items that are possible to use if a district decides to use them. First one's called full width segment correction. And what that basically says is they got to use a diamond grinder or micromilling equipment. You know, that says diamond grinder here because we want to be fair to the diamond grinding industry. If they can cost effectively come up with a piece of equipment that'll grind a 10th mile as efficiently as a micromill, they can use it. But most cases, I think a contractor is going to use a micromill. The spec says they have to pave over it in 7 days. So if you use this item, you know, your district's got to be okay with running traffic on a cold plain surface. This is a micromilled cold plain surface, which is different than a regular cold plain surface. It's there's less likelihood of windshield damage, but there's still a chance. And there's specifications for the micromilling drum. So we're using the same specs as the cold planing specs for the construction part of it. But we're basically saying, okay, it's got to have this drum on it. The teeth have to be a 1/4 inch apart minimum. So, and they have to be within a 1/16 of each other as far as their depth. So, and that adds, when we do that, that adds an opportunity for improvement. That's how we get one extra opportunity. So this full width segment correction, which I like to call skim grinding, it's just taking a diamond or micromill and just dialing it in, put it in automatics and let it go. Skim off 1/8 of an inch. You're trying to touch the whole lane for the 10th mile from the full 12 foot. You're just trying to smooth it out. So rather than going out there with a diamond grinder and trying to hit a bunch of different spots that would take forever, micro mill can just go through it really fast. And we can, if the road will hold up to it. So there's some roads where, if there's a chip seal out there and you probably don't want to take your chip seal off. If it's a rubberized chip seal, you want that as a good layer that you want to overlay. Maybe you don't want to use it. You don't want to skim that off, right? So you wouldn't use that if you're trying to save your chip seal. Then we have something called a partial width segment correction. And this is similar to what we had in the past. We're just leaving it up to the contractor to decide, okay, these 10th mile segments, we're calling them by each segment. Go out there and give us a plan on how you're going to smooth this out. So they can use a diamond grinder or a micro mill. And they also have the capability of using this new 3D modeling. So we saw that in the video. A contractor, there's a subcontractor in Southern California, Pavement Recyclers. They have a lot of coal planers. They have probably most of the business in California. They're buying this equipment to make use of it. So they can scan a road and then, they can have their coal planer go through there and cut to a defined plane. So, we'll see how that works, but that's essentially how that will work. Then when you use this partial width segment correction, it's not an opportunity for improvement, but what we do is just say you're going to use the 60 or 75 target table. You're going to be using this over here, so it's even better. It's a tighter spec. So if they use partial width segment correction, no more percent improvement, we're saying you had a chance to go do what you wanted to do. Figure out where you want to grind. Whatever you do, we're holding you to the 60 or the 75 target table based on your layer thickness. So they've got to provide us a correction plan. So, these specs are all NSSPs. We all worked as hard as we could to try to make them perfect, but they're not going to be perfect. We'll make improvements on them over time if there's an issue with anything. So, right, pavement guys?
Yes.
Okay.
Just a real quick comment on the partial width segment correction. It should only be one additional opportunity.
Yeah, you go to that section and it refers you to, basically says you're going to use a 60 or 75. When you go to that 60 or 75 table, once you go to this table, it doesn't matter what that MRI target is. It's just you're using that table. Yep. I know I scratched my head on that one too, but that's okay. Here's a picture of a skim grind. This was a project up on Highway 49 where they're doing some work. They're going to be. Anyways, they basically had a lot of ALRs that were. Let me back up. So they ran the inertia profiler through this whole stretch of road. There's a couple miles of it. It's pretty a windy road. There's some areas that were MRIs were in the 80s, 90s, and there's other areas where it's in the 180s, 200s, 210s. They decided, rather than doing diamond or using that pre-paved grinding day, they're going to go out and just take a micro mill and skim grind the whole thing. And all those areas that were over 180, they went down below like 120. And these areas that were 80, 90, which way do you think the MRI went? Up or down? Somebody guess. Nobody's going to. Somebody guessed down. Nope, they went up. So, doing this full width segment correction doesn't always give you a smoother pavement, but if you have high MRI values, in the upper 100s, it'll get you down to, in the low 100s. If you have something in the 90s or whatever, you're probably not going to make it any smoother. So, it's good for just, if you have a lot of rough areas in the high, if you go back to this chart here, if you had a lot of MRIs that were, 200s or 300s, you get that second opportunity, you're going to end up with you'll end up with a smoother pavement. So that's the first pass, and here's the second pass. Here's a picture of a micro mill drum. Here's a standard drum, just in case anybody wanted to know what the difference is. And we have the specs define what a micro mill drum is. So it's got to have teeth that are closely spaced. Right now, the spec doesn't have a minimum thickness, a minimum depth grinding. The intent is to kiss the surface with this micro mill over the full 10th mile segment. We're trying to just make the whole thing consistent. So it might be a 1/16 of an inch in some places on average, it might be a 1/4 inch. So, I mean, here we were looking at 1/8 to a 1/4 inch minimum depth. And, you know, when you go try to measure that, it's not really easily measure. You're just trying to skim off a little bit. So that's full width segment correction. Do this for a full 10th mile. You get paid 1 each.
So the only difference between what we had before with pre-paving grinding and this is we're not gonna go and run the inertial profiler after they do this full width segment correction. It's
Yeah.
just considered an opportunity to come back in and do their mill or grind or whatever and then pay.
Yeah, so I'll repeat the question in case somebody didn't hear. Correct me if I get it wrong. So once you do this full width segment correction, are we going to require the contractor to run the profiler on that? No. They will probably, but we're not going to use those values. So when we do this full width segment correction, when you go to that worksheet, the spreadsheet, there's the first column of boxes, you check that, and it basically locks in the MRI 0 value to be equal to the existing surface. They might go measure that afterwards and call it the baseline if they did some structural section repairs, whatever, and then they did this, you know, they'd have to. But we're not going to use that surface. We're going to use the existing. So, but when you lock that into the existing, you know, they got to make sure they increase the opportunity by 1.
So, on jobs that I got to get down below 50 and stuff, we used mills and we set the automatics. And this spec would defeat that because it might be a 1/4 inch in the center. But we used automatics because they have automatics on them, they can go 2%. And when we get to the outside, because of overlays, it builds up on the outside of roadways more often than not. And we would be 3/4 of an inch deep on the outside, and then when we paid for that. When you use the automatics in the machines, that helps extremely, because we took roadways from 180 to down below 60 because we used the automatics. It wasn't because we were just profiling.
Yeah, so these cold planers, they basically have sonic sensors on them. I think some of the older ones, I've never seen one with a physical ski, but they're designed such that, you know, the cold planer is going to try to cut to as smooth as plane as possible. If these tracks are going up and down on the grade, if it goes over a bump, you know, it's going to want to lower the grinder head a little bit. Did I get that backwards? You know, it's going to want to adjust the grinder head. So, you know, the automatics on these cold planers, they work similar to a paving machine where you're trying to, you know, smooth out. You're using an averaging system where you're trying to, you know.
It doesn't react as fast as a paper.
Yeah, but there's a lot of settings in here. And a lot of these guys will say their software is way better than the other cold planers. And this is the end result spec too, right? We're going to go off the existing. It's to their benefit to try to control this thing to make it as smooth as possible so that when they go pave it, they're going to end up, it's going to be easier to get a smoother pavement. Now, the paving crew is going to come through. They might mess all that up, make it worse, right?
Yep.
They got to use best paving practices. And, yeah. Okay, and on this job, they basically, you know, they didn't want to take the yellow stripe out, so they basically let them go stripe to stripe. But when they come back and pave, you know, they want to be skiing off the smoother surface, not off a rougher surface. So, and this is also something I saw in the cold in place recycling over in. There's a couple jobs I drove through where, you know, they had an MRI requirement on top of the CIR surface, and it was really rough. They just took a micromill and they skimmed around the whole thing, and they left the stripe in there. And I put my left tire up on the stripe when there was no cars coming. My left side of my car's balancing like this, and the right side's smooth. You know, you could feel it. You could tell the difference. It was a big deal. You know, this smooths stuff out if they run this correctly. So. Okay, partial width segment correction. This is all new, right? So the contractor develops a correction plan using diamond grinding or micromilling equipment. You know, isolated sections, they can do isolated sections or wheel paths, or they might cut a path for their ski to ride on their paver. You know, there's Don Matthews from Pavement Recyclers. He's got a lot of diamond grinders. He's got a lot of cold planers, and there he has some diamond grinders. I mean, he's big on saying, you know, you need to cut a path for your paver for the ski to follow. The smoother your reference, the smoother your paver will be, you know, which is true. But okay, you know, alternate, they can use some 3D modeling software. You know, I threw pictures in here trying to show what, you know, they might be using. They can scan the surface and come up with a model. You know, when they put this plan through here, they shouldn't be changing cross slopes or profile grades. You know, we're in general just keeping the same cross slope. Okay, so we covered everything for the layers less than 3/10. Now we're going to go to the thicker lifts. So these are basically lifts that are 3/10 or greater. So we know that we can always pretty much break these up into 2 lifts. Here's the spec, just a starburst, just reminding you that now if 3/10, the contractor can break a 3/4 inch type A, break a 3/10 lift of type A into 2 lifts of 1500ths. Our tables are designed so that, we don't want the contractor placing less than 1500ths because then we can't pull cores. We can't do density tests. So we always want the density spec. So we're not going to let a contractor place less than 1500ths. Unless the overlay says overlay a tenth, then you have no choice. But if you have a layer 1500ths or greater, you always have to place 1500ths because we want to be able to pull a core. That's how our specs are set up. Okay, so if this existing surface is over 165, it'll kick into percent improvement. If it's less than 165, we're just going to that 60 table. There's that first table that we talked about. That's where it refers to those. Here's the 60 table. Now instead of $450 max incentive, we're paying $900. And the disincentive is 15 times 190. I think that's $2,850 minus $2,850 per 10th mile. If they left an 80, if they paved an 80 out there, we'd accept it. Where in the past we would have made them ground down to 60, but we're going to take a deduction. So that's the same percent improvement table, the 900 and the minus 1350, but using percent values now. So when you look at this table, this little graphic here is the A team, right? So this percent of target, you think like 75% is not as good as 100%. Well, this table works the other way. We're targeting a number. We want smoother, which is lesser. So the lesser the target, the lesser the percentage of the target, the higher the incentive. So, okay, now this is the percent improvement for 2 ops for 3/10 and greater. So there's no reason to come up and plot something for 1 op because it'll never be 1 op. So if I have a surface that's over 165, I'm going to use this 2 op table. Maybe I have 3 ops, so I'll use that other equation that makes it, if I use a 3rd op, this line essentially goes flat. So now these specs, there's kind of a step in there, and that's how our specs work right now. This is kind of might be an administrative issue, but our mandatory correction level, when it's less than 165, is 80. When we calculate our target using these 2 ops, we end up with 60 at 165, but then we add 25%, and we don't get all the way to 80. We get to a little bit less than 80, so you might have to fix that in our NSSP. So, if these projects that are 3/10 or greater, you can overlay some pretty rough pavement, and, we'll be assured to get decent pavement in the end. Okay, so acceptance criteria using percent improvement, a single lift of asphalt. So our specs define what an opportunity for improvement is. So it's a single lift of asphalt. So it says where an HMA layer thickness allows the layer to be placed in more than 1 lift, the number of opportunities will be equal to the maximum number of lifts the layer can be broken up into, not what the contractor decides to break the layer into. So, it's rare that we're going to see a job with 3/10 of HMA. But if you do, and the contractor decides to use 3/4, or if you write a change order and say, I don't want to use 1/2 inch, I want 3/4, now you're changing the character of the work, but it's going to be 1 opportunity. If you let the specs ride the way they are, if you got a 3/10 or greater, and they decide to use 3/4, the contractor's going to argue that's 1 opportunity. You're going to basically tell them, no, you could have broken it up into 2. That's 2 opportunities. You just lost 1 of them. Still 2 opportunities. Okay, micromilling or cold planing are not in the same shift as paving. We talked about that earlier. That's basically how that spec reads. So if you have the standard special provision that allows the surface to be open for more than up to 7 days, then that's an opportunity. But if you don't have that special provision, And the specs default to forcing you to pave over that cold plain surface, the same shift, and it's not an opportunity. Okay, so the percent of target, that's basically, there's an equation for that. You know, we calculate that target value, and then we basically look at our MRI segment. We call that that's a final MRI value. It's just one number divided by the other. If I had a target of 100 and I paved to 75, I'd have 75% of target. I'm gonna get my full incentive. I think that's an extra slide that I already covered. I should have hid that. Okay, so now again, here's this black box again. We're gonna take all those profiles. You know, we're not asking the REs or contractors to go look at every 10th mile segment and go to those tables and figure out which one you're gonna use. Put it into a spreadsheet and it just does everything for you. So, you know, we're gonna check all the same stuff we talked about earlier. Did they change their data? Did the profiles align? Did we verify them? We get a payment adjustment. Okay, so now here's the guidelines for the design of asphalt concrete pavement smoothness. This is design's guide that provides the designers, you know, the knowledge they need to go design for smoothness now. Like when you say design for smoothness, it means, did you put 2 opportunities in when you should have? That's designing for smoothness, right? If you didn't, guess what? You might end up with a pavement that's over 95 that we have to buy, right? So that's what, and a lot of districts might be okay with that. It's a rural route.